Okay, so hello everybody. My name is Tim, like it says there, and here for that matter. I work for SUSE. I spend most of my time working on high availability, or more recently, cloud software. And some of the time this involves actually developing software and being the upstream for things, and other times it involves taking software from upstream and packaging it ourselves to run on Slays or OpenSUSE or what have you. What is the Open Build Service? It's a, well, as it says on the website actually, it's a generic system to build and distribute packages from sources in an automatic, consistent and reproducible way. There's more information about it at openbuildservice.org, and there's a reference server at build.opensuse.org, which is a running instance of this thing that anybody can go and use. It was originally called the OpenSUSE Build Service. It was first announced in about 2006 or so. A little bit of history of SUSE Linux. It was originally only developed by employees of SUSE, and it was either difficult or impossible for outside people to contribute to the distro. So at some point when the OpenSUSE project was created, the build team from SUSE put together the OpenSUSE build service, which is what we use to build the entire distro. It doesn't just build RPM packages, but it can make ISOs, it can make bootable appliance images and other things like that too. So we use it obviously to build OpenSUSE. We have our own internal instance of it running inside our firewall, which is what the enterprise distros are built on, because for various reasons you can't necessarily let that stuff out of the building until after the release date or what have you. But more recently, it was renamed from OpenSUSE Build Service to Open Build Service to make a point that it's not just for building packages for SUSE. You can use it to build packages for many distributions. So why is this interesting? Why is building packages actually interesting? Ian Lentz had a good line a couple of years ago, which is that a tarball is not a product. I know Bidale was saying the other day that you kind of want your users to be able to become developers, and that's really cool. But back at the dawn of time, your users probably were all developers actually, because you gave, well, or at least they knew how to compile software. You gave them a tarball and they did something with it, and eventually they got a package. But if you're anything like me, you develop some software and you make it available on one or two distros, maybe probably the one that you're actually using yourself, using whatever tools are available. And if you're working on a particularly popular piece of software that all of the major distros have picked up anyway, maybe you don't have this problem because somebody else has solved packaging for you. If somebody else hasn't solved that problem for you, and like if I want to build some software for the distro I'm using on the architecture I'm on, that version of that distro, that's fine, I can do that. But if I want to provide packages for somebody for another version or another architecture, I need another build machine, or at least some VMs, and the number of distributions and versions and architectures, this gets huge, and you don't want to have to deal with this individually because it's a complete pain. So, last time I gave a talk about this, I had a demo at the end. This time I'm going to do it at the start because I think that would be more fun. So, I have here, can everybody see that? Probably not. I have here a very small program. It's a C program and it prints out some text. That's it. Everybody happy that there's no security exploits in this?
No.
Okay. you're not going to want to install what I produce later. Okay, so I should probably show you the make file. It just runs GCC. I have this make archive thing which tells Mercurial to make a tarball for me. And that's about it. So I will make archive. I have my tarball there. Now, if I go to build.openscissor.org, I have an account here, and I can log in. Anybody can get an account on this for free, gratis. And anybody can use it to. Do I have internet? Please tell me I have internet. Yes, I have internet. Anybody can get an account on this thing and go and use it to build packages. There's at least one caveat, which is the software that you build using this public instance of the Open Build server has to be free and open source software, which is, you know, kind of fair enough. I don't have a problem with that. And so if I go to, I'll probably do it up here somewhere. Software is split up on this thing into a whole lot of projects, and I'll talk a little bit about that later. But for now, suffice it to say that every user has a home project within which they can do whatever they want. So I can go in here and create a package, and it's called LCA 2013. Demo package. I'm too lazy to write a description, and in just a few seconds I have a package which is not building anything because I haven't given it any source files to deal with yet. So I'll go and upload my tarball. And now it's still not doing anything because I haven't actually told it how to build. So the other thing I need to give it to build RPM packages is a spec file. You can't get around that. You need some definition of actually how to create a package, and for RPM distros it's spec files. So I'll go and upload the spec file too. And I'll just show you that just for fun, just so that you know that I'm not putting anything terribly bad in here. Package name, version, description. I wasn't too lazy to write a description there. It's not a very good description, but it'll do the job. Yeah, and it's just make and a list of files. And there you go. So back. Can I get those build results chopped up? Okay. So here it's showing me that it's building for a bunch of different distributions, and you can actually go and look at the build log while it's running too to see what it's doing. Well, it only took 30 seconds because it's not a terribly big package, but now that I've done that and I've got some builds, any of you who are feeling really brave can go here to build.openscissor.org to my home project and can click this download package button. At least if you've got CentOS or SLES, because it obviously hasn't finished building the other ones yet. So you can go here and get that package, and I'm done. My package is now available to the world for at least a couple of distros. So I might jump back here again. Apparently nothing went wrong, so that was good.
You haven't downloaded it yet.
Oh, yeah, right. Yeah. do I have a build for OpenSUSE yet? Guess not. Almost, it's still building. I'll get that later. So, what's all going on underneath here? There's the OBS server itself, which looks after users. It's got databases of things. You can search through it for packages. There's a whole lot of storage. There's a whole lot of build hosts. So when you actually kick off a build of something, it will go and spin up a VM instance somewhere. Install all of the necessary dependencies to build your package, and then it will build your package in there. And this is how it meets those the consistency and reliability thing that I talked about before. Because the build environment is always completely clean. If you're building something on your desktop system, you might have extra stuff in there that you've forgotten to add to your list of dependencies of your package or whatever. Because you get a clean build environment every time, you know that you've got those reliable, consistent builds. The mirror interface over there is how packages make it from the storage to the rest of the universe. They end up in RPMMD repositories, so you can use them with Yum or Yast or Zipper or whatever. I'll get to Debian in a second. There's a notification server. You can subscribe to notifications when builds fail or succeed if you really want to receive a lot of email. I suggest not subscribing to the success ones, just subscribe to the failure ones because they're the ones you have to fix. The server itself has a REST API, so there's a bunch of ways that you can talk to it. And what I was doing before was using the web interface to obviously talk to the backend. There's also a command line client called OSC, which is available for, you can, incredibly, this is built using the Open Build service, so in the Devel tools repository you can go and get the OSC command line client for many and varied distros, and then you can use that from the shell, and you can do interesting things there because all of the source for all the packages, the tarballs and the spec files and everything, is actually in revision control on this thing. So you can go back and see the changes that you've made to your packaging of something over time, and you can do diffs from one to the other and all that sort of thing. At the moment, apparently there's about 32,000 confirmed users on this system, 51,000 package builds per day. Personally, it seems to be more heavily loaded when Europe is awake, which means that's okay for me because my builds schedule immediately during the day in Australia. And in terms of distros supported, all of these ones. A couple of SUSEs, a couple of Red Hat-y things, a couple of Debian-y things. Arch Linux is a recent one that got added sometime in the last year, probably, I think. So I've just gone and built an RPM by uploading a tarball and running a spec file. If I want to package that for Debian as well, I will go back to my web browser, which I'm being confused by. Sorry. If I want to build it for Debian as well, I have to give it a few more things, which I prepared earlier to save me writing them now and screwing up the format of the changelog file, which will, if anybody's ever screwed up out of a Debian changelog file and tried to figure out what you've done wrong. But maybe that's just me. I don't do a lot of Debian packaging, actually. So, Debian changelog. There's nothing in that changelog. It just says initial packaging by me. Control. The other interesting thing here is that these files that I'm adding, the changelog and the control file and the what's the other one? The rules file and the DSC are the minimum set of files that you need to build a Debian package. And OBS will do the right thing with them to make the build work. I've approached this from the perspective of somebody who's used to packaging RPMs and had already written a spec file, so I've just gone and written these extra Debian files as well. But if you were starting with an actual Debian package made with dpackage, create package, or whatever the command is, if you were starting with that, you could actually upload that to OBS, and with all of those Debian required pieces that have been generated for you by the Debian package helpers are there, it will use those, so you don't need to do this stuff. You would then just go and write a spec file to get your Debian thing to build on an RPM-based distro.
Do you mean it will look inside the table for that?
If you've got a Debian package as produced by dpackage, is it create package or something else? Package source?
Dpackage source.
Dpackage source. If you've got the thing that comes out of that, with the Debian subdirectory in the right place and the right files in there, then it will do the right thing with that. And just see what's going on here. Okay, so allegedly I've got a build going for Debian 6. This excluded thing here, see that little icon with the little what's it there? When I upload a new file, it figures out whether or not it needs to recalculate any dependencies or figure out if new builds need to happen. And so there can be a little bit of lag there while it's figuring its stuff out. But oops. Okay, and we purport to have a Debian package, and I've got a OpenSUSE package as well, so I can try that download now. No, I can't. It's lying to me. I didn't pray to the demo gods this morning. Okay, I'll come back and try and do that again later. Sorry. There we go. Okay, so that's distros. Project model. I mentioned before everything's in a project. You've got your home project, and there's other projects. A project contains a set of packages and defines what distros those packages will build for. And there's other settings you can do in there as well. If you've got dependencies that have different names on different distros, you'll find that SUSE uses lib, foo, devel, and foo, devel, libs, or whatever way around this is. You can set up in the project configuration, if this is on Fedora, substitute this package name in the spec file with this one, so you can, to a greater or lesser extent, depending on how complicated your spec files are, you can do away with having to have a whole lot of, if Fedora, if whatever in your spec files by setting it up at a project level. So this is meant to represent that the project can build against these two distros, and it's got these packages in it. The other thing is that projects stack, so they build in terms of each other. Like my home project is building things for OpenSUSE in terms of the OpenSUSE 11.1 project. So that's where all the dependencies for my project come from, through that stacking. But there's no reason that like these graphs could be longer. For instance, if somebody's got a newer version of, say, KDE or whatever in the build service, and my software builds against KDE, I can change my project to not build against the base distro KDE, but I can make it build against that other project and get whatever newer thing that I need. Okay, so, and this is where I'm about to get into another demo. Because all the packages are under revision control and there's multiple users and multiple projects, This means that somebody else can come along and they can branch a package from my project, and then they can fix things that I've screwed up because they're really nice. Well, we hope. And then they can submit those changes back to me, and then I can see them and review them, and I can either tell them very politely to go away because their fix was wrong, or I can thank them profusely for doing my work for me. So that means it's time for another demo. If I go back now to my web browser and I log out as me, and I log in as someone else, okay. Someone else hasn't done very much yet, isn't involved in any projects or anything, but I can go here and I can go and find, I as someone else can go and find Tim's LCA 2013 demo package, and I can branch that. Am I clicking through this too fast? Is this okay? Yeah, cool. Yes, I really want to branch it. This branch will then end up in a sub-project of someone else's home project called Home Someone Else Branches Home Tisserong. Now, if I go to my shell and I become someone else, do I even know my password? Good. Okay, this is where we get to see the command line client. Back over here, that project name that I'm highlighting there and the package name, I can run OSC, which gives you a whole lot of help, which you shouldn't read on this screen. It's going to take too long. OSC check out from that project that package, and I'll low down the screen there. Okay, oh, yeah, right. So this is going and talking to the OBS server using the API, and this is checking out all of those files that you saw that I uploaded there before manually. Someone else here in that directory has all those files. Now, someone else has realized that the message that was printed out by my program didn't actually include the year the conference was on. So I can go and, how many people here are familiar with Quilt and that sort of thing? Yeah, cool. That's enough. So I'm going to go and patch the source. Sorry about that prompt. Which is Quilt new year, Quilt add 2013, and we're going to go and change the year here. Quilt diff. So that's the patch I've just created. Quilt refresh. Okay, now I have to go and edit my spec file, wherein I will put patch year patch, and I will tell it to patch. Now, OSC status, because this is revision control, there's some stuff in here. It's telling me that the spec file's been modified, and there's a couple of unknown files. There's a series file, which I don't care about. and there's the patch file. So I will OSC add year.patch. And this is, because I'm making changes to a package, this is a really good time to update the changelog. So OSC VC will let me, oh wow, that's my other email address. Add year. Okay, so see status. Better add the changes file. So 2013 changes. OSC diff will show me what I'm about to commit back to the server, and OSC check in will go and actually do that. In just a second. Any time now would be good. Thank you. So now if I go back to, now if I go back here and reload this page, I should see there's my patch, there's my changelog file. Back here I can go and actually look at the revision history of the commits to this package, but I mean that's mostly boring now because there's only one. And we can see that according to the status it's doing various builds of things. So I, someone else, am now happy with my changes, and I would like to, where's that link up? Sorry. Okay, I would like to submit that package back to Tim. Someone else is going to submit these changes back to Tim so he can go and look at them. So add year to printed out. And here actually I have the option to remove this local package if the request is accepted. So if you're just midnight patching, run in and out, patch gone, yeah, and you don't want to look at this project anymore, you can do that. You can branch, patch, submit, your thing gets deleted, you don't have to worry about it anymore. Or you can keep it around for a long time if you plan to keep working on it. But someone else doesn't plan to keep working on this, so that local package can be removed if the request is accepted. And the internet's always slower when you use it during presentations, I don't know why. So now, if someone else logs out, and if Tim logs back in, I can go and look at a list of requests that have come in to me on projects that I'm involved in. Just for entertainment, that first one there, OpenSUSE maintenance, whatever it was a, this is a request that I submitted to OpenSUSE to fix some bug, and this means it's actually gone through the maintenance process. So the Open Build service has, somebody on the maintenance team has reviewed my thing and has accepted it into the updates repository, and then it's gone out into the world. Somebody declined my RabbitMQ request, which is fine because somebody else fixed that. And here, the third one there, you can see someone else has put in a submit request for my LCA 2013 package, which I can go and look at, and it shows me the changelog, the change to the spec file. It shows me this new file that's been added. If I'd actually gone and uploaded a different source tarball, it would actually pick that apart and show me the diffs between the inside the source, which is really cool. But because I, Tim, trust someone else, Tim, I'm good with this patch. And I will accept that, and then that will be applied to my copy of this package, and that will build, and then everybody else can go and get this new improved test program that actually prints out the right year. This request, this submit request process, you can have more steps to this. You can have users within a project that have different permissions. You can have someone who's got full permissions, someone who, Andrew, yeah?
Maybe I missed something. Are those requests already tested? Have they gone through the build system first? Because, I mean, if you get, I'm much more likely to accept a patch that's,
Yeah.
I know at least has produced a viable package once.
Okay, so the question was, have those requests that come through, have they already been built so that you actually know that they work? I accepted that quite quickly, and at that time it may or may not have been built yet, but somewhere on that page, which is, well, somewhere on the previous page where you accept the request, you can see what the build status is in the project that it came from. So you can see, you can review the patch and you can look at that and go, oh, okay, it actually did build in the submitters repository as well. So actually, you, the person reviewing the patch, it's good, it's built, done. Now I will accept. Yeah, does it? Yeah. Yeah. Okay. So you can have users with different roles. So you can have somebody who's only a reviewer. Who if you have a larger team who would just go, yeah, okay, I've reviewed this and it's good, but I don't want to actually accept this yet until the lead developer also accepts it, so you can have a bit more process to it if that works for you and your team. Okay. Now, I can go back to, oh wow, there we go. Go back here and see if I've got anything to download yet, so I can, oh look, CentOS build failed, it said. Maybe the patch was dodgy. Maybe I should have waited to see if someone else had actually produced a viable build. Dodgy bugger. So it seems that I do actually have a download of this one version or another, and what else is going to do? I never use Yast for installing software. I use command line things. Okay, go. Yes. Yeah, okay, that's why I never use this to install software. I should mention also that there's a GPG keys generated for each project, so they automatically get signed by the project's key. So you know that the build has some integrity at least out of the build system, provided you of course trust the people who are running the build system, and well, I do. Oh, look, here we go. It's telling me that it's found this this GPG key in my home project, and I should probably trust that, or it's not going to let me install the software. And how many dialogues does this thing have? Sorry. Okay, so now if I go back to my terminal, I can run that, and okay, that's the old pre-patched one. But anyway, the point is that software was built, downloaded, installed, and this was more or less completely painless. And I've got builds of this thing for like 4 versions of 8 different distros without having to go to a lot of trouble. And let's see what we're up to now. That's that demo. So some random points about OBS itself. It's all free and open source software. It's under the GPL. OBS is on GitHub, so you can go there and play around with the source. Okay, so the web front end is Ruby on Rails. The back end code is a whole lot of Perl and Shell and other bits and pieces. So it's largely those languages of that nature. And in terms of this graph's a bit pale, perhaps, but you can these are the commits to master from 2006 up to 2012. So we can kind of see that there's been a fair bit more work going on in the last few years than there was initially when it all started up. Who's using this thing? We are, obviously. There's a whole bunch of other people using it too, various communities, Intel, Cray, Dell, some other people. I'm not entirely certain what Microsoft are doing with it. Anyway, Dell's kind of an interesting case, and I'm really sorry to point this out to Dell on something that's being recorded, but I think it's a bad idea. Dell. This public repository of theirs, of various software, there's like firmware and bits and pieces in here. Have a look at these setup instructions. Just here. Can anybody tell me what's wrong with this?
It's coming from a untrusted, unencrypted HTTP source. You're piping straight to a shell.
Oh yeah. Yeah, I went and looked at the CGI script, and anyway. No, it's fine. It's not doing anything bad. Okay, it's completely kosher. It's just if it was me, I would have printed out the instructions to go here at this repository. Sorry, I've seen this, and I don't want to pick on Dell, but I've seen that in a couple of places on a few websites. But here's how you get our software: you pipe something straight off of out of wget into Bash, and it terrifies me every time I see it. Yeah, exactly. So I'll stop bashing now. I'm fairly nice, actually. Okay. So that's other people using it. VLC project apparently uses it. Pac-Man, but that's other stuff for OpenSUSE mostly. If you want support for it, there's people on the IRC channel, OpenSUSE build service on Freenode. There's a mailing list. You can get professional support for it from B1 Systems. I think they're in Germany. And it's probably a good time to segue into other things I should mention. So, earlier I was creating tarballs myself, and I was uploading them to the build service. There's another way of doing this. You can make the build service pull a tarball directly from somewhere else. Last time I gave a talk about this, which is kind of funny because last time I was in Canberra, I actually gave a talk about the Open Build Service, and I was in this same room, which is really kind of creepy. I wonder if it'll happen again. So a story that I told last time I gave a talk like this was, if I go back to my home project again, and I go back to the packages here. One night a couple of years ago, my wife and I were at a friend's place for dinner with her laptop for some reason. And somebody asked me at the time, is there any astrology software for Linux? And I had no idea at all if such things existed. But I Googled around, and it turned out that there was one called OpenAstro, and whoever it was that wrote this thing has a Ubuntu PPA and they'd made an Arch package available, but they didn't have anything that would run on SUSE. They only had a tarball. So what you can actually do, I still had to write a spec file for this thing. But there's this concept called service files, and if you have a look at this, it's a little XML file which says, go and download this thing from here. And so when the build runs, the first thing it'll do is it'll actually go and get that tarball for you, and it will run this completely on the server. So I actually sat here at dinner in my web browser writing a spec file in the little in-page editor here, and a service file, and then went, okay, go. And the thing went away and pulled the tarball down and built it, and then I was able to install it, and I had a delightful new piece of software at the end of dinner. So that's one thing. But another thing about where the service files get a little bit more interesting is you can use them to pull straight from GitHub. Or GitHub, Jesus. GitHub has become Git in my brain. This is not a good sign. Okay, so if I go and look at, I'm going to randomly pull something out of an OpenStack project of some description. This is another example of stacking projects and having sub-projects. So the idea here is, OpenStack Essex packages that somebody's working on go into this staging project first, and then they're only allowed to go back here once they've been through testing or the build works or whatever. So you can, again, there's lots of interesting things that you can do with workflow and teams to sort of work together and make sure that things end up in the right place. Actually, because this is all, because OBS has APIs and everything, what we did internally on our internal instance of the build service, we've got Jenkins running somewhere to run tests of OpenStack, and somebody set up this Jenkins job to go and get all of the upstream source for OpenStack, shove it into OBS, have it build, check whether the build worked, then go and install that on some test VMs. This isn't part of OBS, this is something that uses OBS. Go and install all those packages in some test VMs, run integration testing, spin up an OpenStack setup, and once that's worked, then it would go and automatically submit those packages that were known to be tested to our stable project, if you like, which is actually a longer answer for Andrew's question before, which was somebody wrote this extra stuff to using the APIs to get packages in and out and also run tests and then shove things back in. So you can do that because there's a command line client or the API if you want to play with that. You can do those sorts of things if you want to write some extra stuff. Yeah, so what I was going to randomly pick in glance, the service file here. Notice that terrifying tarball name, git.timestamp.oh god. Okay, so here, it's pulling from GitHub, version git master. It's probably going to, is that going to take the, no it's not, no that's okay. Versions and version formats, these things actually end up in the tarball name. And you can make sure that it actually checks out a specific branch or a particular commit, actually. So once you know that some upstream source is right, you can write a service file to only pull that particular commit out. And internally that does a git clone somewhere, and then this recompress thing makes a tarball out of it with a file name in some format. And one of the things that's probably not in there, there's actually a thing that you can make this do, so it will rewrite the version in the spec file as well. So based on something that it got from upstream or whatever. So this means that you can almost once you've set it up once, if you want to track upstream changes, you either take head of upstream and hope they never check in anything really bad, or you end up only just changing the commit IDs, and you can either see the tar SCM mode is disabled thing there. That means this won't be running all the time, but you can, with the command line client, you can go OSC service disabled run, which means run the disabled services, and it will at that point go and do that pull and compress and everything. But anyway, yeah, so that's service files are a good thing. But it saves you making your own, saves you having to make tarballs and shut them around yourself all the time. Devel projects, I kind of alluded to that a bit with the stack projects thing. With OpenSUSE, we have, there'll be a project like OpenSUSE Factory is the next release that's coming, and there's a whole lot of packages in that. And each one of those is not, people don't work on it directly in that that main OpenSUSE project, because that's the one that the ISOs and everything get built out of. Instead, each package has a Devel project, which is a separate project which that package is developed in. It's kind of roundabout. To give an example, there's a repository network HA clustering factory which has pacemaker and Corosync and the HA bits and pieces in there. And it's just that handful of HA packages, and the maintainers of that repository are myself and about half a dozen other people. And so what we do, if we want to get a new version of one of these things into the next OpenSUSE release, is we work on it in that project where we can break things if we want to. And then once we've got it to a state where we know that it's working and it's stable and everything, then we create a submit request to OpenSUSE Factory, and the build team or the release managers or people who have responsibility for the whole distro will then accept that request, and then that goes into the next version. Cross-compiling. This is kind of fun. Some people have been doing an OpenSUSE ARM port for a while, and I think there's a reasonable version of OpenSUSE 12.2 which will run on ARM boards of various types. But there wasn't actually any ARM hardware in the build farm anywhere. So what's happening at the moment, I think, is it's spinning up a KVM instance on x86, and then it's using QEMU user something or other to run individual ARM binaries emulated. So it's not emulating the whole system, because that would, it's not booting up a whole ARM architecture Linux install, because that would be horribly, horribly slow. Most of it's native, except for the individual commands that get run emulated. And it's still slower than it would be if it was cross-compiling, but it also means that you don't need to change any of your source code or do any of those other weird things to cope with being cross-compiled. There's more work going on in... Sorry?
I was going to ask, is that using a modified version of QEMU? And QEMU user mode emulation, particularly on ARM, has been for a while somewhat.
Yeah, so the question was, is that using a modified version of QEMU user mode? Yes, it is. We, not me personally, apparently patched the hell out of it recently to fix lots of things and make it work right. Those changes are, I don't know whether they've made it upstream yet or not, but somebody's on the hook for making sure they get upstream. So there's something going on there. Interconnect, you can have different OBS instances talking to each other. For instance, our internal one talks to the external one, so we can take, on our internal instance of OBS, we can say, make me a copy of this package from OpenSUSE. So this is how we can take things that have happened in OpenSUSE and pull them into our internal build service easily to use them for, you know, a newer version of SLES or whatever. And the other thing is, I've been talking about the one that's on build.opensuse.org because, you know, anybody can go and use it. except, as I mentioned, if you happen to be building proprietary software, or there's something that you need to keep secret, or you want to use your own hardware because you're going to build something that builds everything 1,000,000 times quicker than our one because you've got SSDs everywhere and hundreds of millions of dollars to build giant farms, whatever. You can go and run it yourself. There's two ways that you can, probably more than 2 ways. You can go and install the various OBS packages on OpenSUSE probably. And there's documentation about how to go and do that and dependencies and all the things you need to install. I haven't tried this. Apparently it's difficult. So somebody, upon having realized that it's apparently difficult, has gone and made this OBS appliance image thing using SUSE Studio. So you can go and download a disk image, and I don't know if you can run it in a VM or not, but if you boot off that disk image on a system that you don't want to use again because it's about to wipe out your hard disk and install and completely image it as an OBS server or worker, you go and get that disk image, you stick it on a system, turn it on, come back a little while later and you've got a running single host, so you're only going to have one system doing builds, but then you can go and deploy this thing on a bunch of other systems and you can make them all talk to each other and set up a build farm. That's markedly more straightforward than actually trying to install and configure all of these bits and pieces. So there's something that people with more spare time than me can go and play with if they like. I should also mention on that note, another interesting use of this is I actually think this is a sort of system that would be useful for possibly as Dell have done actually. For anybody who's deploying, if you're deploying a stock Linux distro out in your environment, but you have some custom packages specific to your environment for doing, I don't know, science or whatever it is that you're actually doing yourselves, rather than manually doing a, configure, make, whatever it is that you do, you could use OBS to then just build those. You might not be planning to give these things away necessarily, or you might be, but you've got a reliable way of building packages of your in-house software even that you can go and deploy in your standard operating environment or whatever it is that you're doing. So might be something interesting there. And let's see. I've got a bit of a feeling I'm done actually. Unless you want me to try and fix that build failure from before. Any questions? Wow, everybody.
Can you make it look like a repository? So say you're building your own software in-house, is it just the metadata that makes
yes.
it like that?
Sorry, question was, can you make it look like a repository? If I go, I won't go to that one. I will go to my home project. Yeah, sorry, that little download link is, you can actually, you can embed that page in some other website if you want, so you can go get my software for pick your distro, but you can actually, there is a real repository behind all of this. So if I go and look at, let's go and look at that one. So here, download.opensuse.org, repositories home, tsarong. There's all of the distros that I've been building for. And if I go in here, there's a repo file which rpmmd foo, and you can point anything that can understand that type of repository at that directory and use your package manager to, you can add that as a repository to your system and away you go. You had one?
Yeah, the build VMs that you mentioned before, how tough are they to, like, I imagine that it'd be more than just build a VM. Is there a configuration script that will go and set everything up so that it's ready to be used by the OBS system?
It happens by magic. Sorry, that was how are the VMs set up. Let me see if I can dig out a build log. See if I can. Okay, so here we go. Okay, so it doesn't really say much to it. Doing KVM build, pre-installs a whole lot of packages. Boots KVM, boots that system up. I actually don't know specifically how that's defined, but it works. It happens by magic. Oh, that's another thing. So you can build. I probably shouldn't do this here, but using the OSC client. Oh, sorry. It could be someone else again. Actually, this might not work because I deleted the project. No, I deleted the project. You can run OSC build from your shell, and it will go and either build everything in a chroot environment on your system, which you might not want to do if your dependencies were written by crazy people that you don't trust and not try to break out of a chroot. But you can also make it do the same thing that OBS does and spin up a KVM instance and do the build locally on your machine there. So and actually I would tend to recommend that you just do the builds on your own machine before checking them in, because otherwise you'll get a build failure like I did before, where I obviously screwed up that patch somehow. If you keep using the same, if you keep reusing the same build route on your system, it'll cache all the packages in there. So the first time you do it, it will download a couple hundred megabytes of RPMs to populate the build route. But the next time you do it, it's only going to download things that have changed. Which is another point. Also, when OBS is building things, if any of the dependencies change, your stuff will get rebuilt automatically to match. So, yes.
What about testing? Like, you can build a package, and it's still not guaranteed that it'll work. You might run into problems in runtime, like with things that you haven't foreseen.
Yeah. So the question was, what about testing? It builds fine, but it might not run. OBS doesn't try to solve that problem. It will do some. It does some things, like it runs RPM lint and some other bits and pieces to try to make sure that your packaging is kind of okay. I think we'd let's see. Yeah, that would tend to be the purview of external tools. So once you've got your package, then you can go and run test suites with that. I mean, you can, if your software has a test suite built into it, there's no reason that can't be part of the build cycle. You can have you can have that happen if you've written those tests, but that's not necessarily the same thing as a person using it in the wild. But you can integrate tests into your build process, but insofar as you can do that in the spec file or in your make files or whatever. I don't think there's an extra. There's only as much magic for that as you put in yourself. How's that? Yeah.
The hooking up with GitHub to actually, to git clone and make a trouble and throw that in there. What I've read, you basically have to, if you want to have something like a pull request gets accepted, to have OBS automatically start spinning a new package, you have to actually authorize something on GitHub to push that to OBS. Is there any way for OBS to sort of say, I want to actually monitor that GitHub source, and when people accept pull requests, I'll start?
So the question was, is there a way to have OBS monitor the source on GitHub to see if commits that you wanted have actually made it into the tree that you're trying to pull from? And the answer is that I don't know. If there's a way to do it, I'm not aware of it. So I'm sure the patch is accepted. The plugin, the OSC client has plugins for doing different things, and there's plugins to pull from SVN and plugins to pull from Git and plugins to whatever. Okay, so the source for these things is somewhere on the build service. So that would actually be a really interesting question to ask on the OpenSUSE build service mailing list. I can think of a couple of my colleagues who would actually really love to see that implemented. I don't know if they have time to do it themselves, but actually I might mention that myself because one of them might.
I guess the follow-up there is how annoyed the OBS would be if you were rebuilding packages every 2 hours or every hour when people were committing new stuff. How annoyed would OBS be if people were rebuilding packages all the time? On the one hand, that's kind of what it's for, to keep rebuilding packages when things change. I don't know what degree of congestion that would cause. There are graphs and things showing how many build hosts are active and what all's running at the time on the build service website. So at some point, if enough people were doing that, it would put presumably enough load on the system that all of the scheduling would slow down because so many things were being built, at which point I hope that somebody would wheel in some more hardware. So, yeah.
And how long do they keep the different like the RHEL versions up there? Do they, is version 3 up there of RHEL, or are they each and every one of them?
So the question was, how long do versions of different base distros get kept up there, like RHEL? The answer is I'm not sure. It's not forever. Even the SUSE ones aren't forever. Like the 11.4 or something got moved to discontinued, and then later on it's probably actually none of the OpenSUSE ones will vanish completely. They don't remain around forever, but what's on there at the moment, I'll see what's on there at the moment actually. If you go in your project, if you go into repositories and, repositories are set at a project level, so you can't. You can change what individual packages build for at the package level, but you can only add more repositories at the project level. So by default, right now, we've got OpenSUSE 11.4 and newer, SLES 10 and newer, Debian 6. This is interesting. A couple of years ago, Debian 5 was listed there, and I've still got builds running against Debian 5, but it's not listed here as one that you can add now, at least on that default page, which maybe that means it's going to disappear, I'm not sure. Fedora 16 through 18, RHEL 4, 5, 6, CentOS 5 and 6, an assortment of Mandrivas and an assortment of Ubuntus. So it's in, I mean, if you look at those, they're sort of the last, it's kind of at least the last 2 or 3 versions of everything. Yeah.
Are there major versions as well? Are they, like, it just says like 4, 5, 6, or is it, does it break down further at any stage?
No, it's just those yeah, just those major versions. Yeah. Yep.
I noticed when you added the patch, you modified the RPM spec file, but didn't change anything for Debian. Do any of that magic to make that?
Okay, the question was I added a patch to a spec file, but I didn't change anything for Debian. I was really hoping nobody would notice that, actually. Thank you for proving me wrong. It means you're paying attention. No, it doesn't do any magic for that. So I should have gone and also added the patch to whatever relevant Debian file would make that apply there. I didn't because I would have had to read some documentation to find out how to do that. So,
Okay, so if there is no more question, we will end the session for this morning, and we will start again at 1:20 this afternoon with packaging for OpenStack with Monty Taylor.
Thank you.